another piece of the electronic load gets put in place. The user input and information display are on one PC board. There were a few things I wanted on the user input side. A switch to enable and disable the load, a switch just for that, and a switch to change operating modes. Then added a switch for like a menu or some auxiliary function. Figured I would have room, and how could anything usable just have two switches? Now I like a knob for changing values up and down, much more so than up and down buttons. And there's not going to be room for a keypad, so it's input by knob only. So I have an encoder here for the knob. It also has a switch on the shaft, so it can push the knob to activate the encoder for a bit of time. That should help eliminate accidental adjustments. I did go with RGB LEDs for the three switches. A little bit of color as feedback should work nice. Help give a bit more information considering the limitations of the OLED display. To display the information, I'm using a small 128 by 64 pixel OLED display. It's getting a bit puny as displays go these days, but I still have a few of them lying around. Here, the communications with the control board is through an asynchronous transmit and receive channel. I have the Tag Connect programming header I almost always use. I added this RJ25 connector at a late date. I wanted to be able to program the microcontroller without removing the board, and this seemed like the most practical solution. The board is powered by a small switching regulator IC. Should work fine with input voltages anywhere from 5 to 16 volts. For the microcontroller, I'm using one of the smaller 16-bit dsPIC ICs. Overkill here, but I've gotten where I really like these. And it makes it easier to deal with the display if I use a controller with at least a couple K of RAM. So why make life harder to save 50 cents to $1 on the chip? For the layout, I wanted the encoder to be on about the same line as the OLED display, and I wanted enough space between them for my fingers to fit around the knob without blocking the display. You can see my right-handed bias here. Display on the left, knob on the right. The switches are spaced 1 inch apart. I needed that space for my lighted acrylic buttons. The RJ25 programming jack is here behind the display. I had already laid out most of the PC board traces when I decided to add this. So instead of ripping up the traces and rerouting, I stuck it where I could find space. This 0.1 inch pitch header here is the connection to the control board. I've never done a good job of putting test points on my boards. I'm doing better at it now, but I still need to improve my selection of which nets need a test point and which nets it would be nice to have a test point. This was the first PC board I put together after getting the hot air station. I had only done a few test boards to get the feel for it, but it's not the same as putting on a variety of parts. I almost always install the parts for the power supply section first. That way I can test it to make sure it's working properly. Last thing I want to do is run 12 volts in on a 3.3 volt microcontroller. Now I put a bit of solder on all the pads. Here I was still running the soldering iron a bit hotter than it needs to be. If I preheat the PC board a bit with hot air, I can run the iron at a lower temperature. And at the lower iron temp, the flux doesn't boil away, and I do believe a little more solder is left on the pad. I put a thin layer of flux on the soldered pads, and then position the part, getting it aligned as close as I can. Then the hot air. Using the hot air station has really made installing the surface mount parts much easier. This is another one of those tools I wish I would have bought a long time ago. The most time-consuming part now is placing the parts. I feel by using the hot air, I've cut my board assembly time by at least 30%, and I'm very pleased with that. These spacers for the display seemed so tiny when I was making them, but they look huge when mounting the display. I even had to enlarge the holes in the display. The smallest tap I have is for 256 threads, and that's a tiny bit larger than the 2mm holes in the display. This is where there is a bit of a problem with my programming jack. Of course, the only ones I had on hand had the release tab on the mounting side. So these jacks really need to be mounted on the edge of the PC board. But I didn't want to reroute, so it's difficult to remove the cable from the jack, but something I can live with. Display and user input seem to be working. Got a lot of finishing touches that need to be done. That display is really tiny, and I need to redo the bitmaps for my character set. They are a little rough. Button LEDs are a bit too bright. I'll see if I can fix that in software instead of replacing resistors. But overall, it's working as I had hoped. Now it's time to move to the hardest part, measuring the current, voltage, and controlling the MOSFETs. A lot of testing ahead. Thank you for watching.